Sometimes you need to create new variables in SQL. So this would be the equivalent of a transform recode into a new variable in SPSS, or it would be the equivalent of some if-thens in a SAS data set. So I think the easiest way is probably to illustrate this with an example. Let's go back to our employee data set. And remember, in this employee data set, there was a variable training level. And suppose that we wanted to create a new variable that's a dummy that indicates whether or not the training level is low. So training levels value 1 are low. So anytime that training level is 1, we want to set this dummy to 1, otherwise it's going to be 0. How do we do this? Well, there's two ways of doing it. You can either do it in a select statement or you can do it in an update statement. I'll show you both ways. So let's start out with the select statement. So I'm going to make myself a new table. Let's call this table employee, but I'm not going to keep all the variables. So we'll just keep the employee number, the training level, and then the age in years, which I'm going to use in my next example. Here's this case statement. So notice I'm still listing variables. So it's employee number, comma, training level, comma, age in years, comma. Now that comma is telling SQL that you should expect another variable to come. And so that other variable is actually way down here. It's going to be called training level, or low train. So low train is that dummy. What is low train? Well, we're going to get at this through this case statement. So the case begins with case, and it begins with an end. Now, case says this. Let's consider some variable. So which variable? Training level. And then I'm going to tell you what to do for each of the values. So this is completely equivalent to the transform recode in SPSS. So case training level, whenever training level is 1 is the way to think about this in English, then the new variable will take the value 1. So that new variable is going to be low train. I could have as many of these when, then commands as I like. In this case, I only have 1. All right, so whenever, let me translate this into English. So when training level is 1, then low train should equal 1. Else, low train should be 0. So that's exactly what it does. We're going to do this from the employee data set, and then let's print the employee number, the training level, and low train from this employee data set that we just created. Now I've included the out obs equals 10 option, which means we're only going to get the first 10 observations. So let's go look at what we have. When training level for that first record is 2, notice low training is 0. Then finally, the third observation, we encounter a 1, and so low train is 1, and so forth. And if you looked out through the entire file, if you find some training levels of 3, low train would also be 0 on those. The other way that you can create new variables like this is with an update statement. And the update is a little bit more flexible than this select case. So the select case is really good for categorical variables. This update statement will also allow you to do ranges, where to my knowledge, you cannot do them in the case select statement up above. So let's make a new variable. Here's the task, age bin, which groups employees into 3 bins, less than 40, 40 to 50, and 50 plus. So how do we do this? Well, we're going to use the alter table command to add a new column. So we're going to tell SQL that this new column should be called age bin, and it's going to be of numeric type. So now we have a blank column with nothing in it. We must populate that. How are we going to populate that? Well, we do that with an update statement. So let's update this employee data set. We're going to set age bin, this new thing that I've just created, equal to this thing that I've enclosed in parentheses. So let's talk about what's in parentheses. Here's the syntax. Case, when age is less than 40, then assign age bin the value 1. However, when age bin is between 40 and 50, remember that between includes the endpoint, so if you're exactly 40 years old or exactly 50 years old, you're going to get assign the value of 2. So when age is between 40 and 50, then assign age bin the value of 2, else give it the value 3. And then this ends the case statement. Now if I go select the employee number, age in years, and the age bin variable from this employee data set that I've just modified, you'll see the result. So first person is 42, goes into age bin 2, looks right. Second person is 54, age bin 3. If we look down, here's a person who's 30 and goes into age bin 1. So it looks like this statement is working right. Let's now talk about another really pretty big and important topic. And I'm going to give you just a little taste of this topic for now. This is the whole topic called subqueries. So a subquery is a query that you run inside of a query. Now you can go read, I think this is in chapter 2, several sections on subqueries. They get into different types of subqueries. I don't use them that much in my database marketing work, and so that's why I'm only giving you about 2 slides on it. But I thought I'd give you a couple examples to show you about them. All right, so let's start out with an example from the DMEF1 data set. So let's say I wanted to run a frequency distribution. Well, I could do that in SAS. How would I do it in SAS? I'd use procfreq, and let's get a frequency distribution of the code type. So I think we've already done this, and you'll see that there's really, 6 different code types, 5 of which account for most of the cases. Well, we could generate a frequency distribution, something like this, in SQL. Here's the way we're going to do it. So let's first off select code type. Then let's pick the count of code type as count, and I'm going to do this grouping by code type. So that's going to give me 1 row for each unique value of code type. So this row is going to count the code types for every unique value of code type. How am I going to get a percent? Well, one way to do that is with a subquery. So let's pick the count of code again, and I'm going to divide that by this thing in parentheses. So all this stuff in the parentheses is a subquery. So what's the subquery? Well, the subquery is going to be, let's count all values of code from this data set. So you can think about this, this is going to return 6,615. So what we're going to do now is divide the counts by 6615 from the subquery. So here's what you get. And you'll see you get exactly what you got upstairs without the cumulative columns. So that's one example of a subquery. So you just put it in parentheses, and then the results of that come back and you can use in your code. Let me give you another example. Suppose that we wanted to generate a table that had all the transactions that resulted from a solicitation of type A. So how would we do that? I'm going to show you 2 ways. One using a merge, which is probably the way you would think to do it after all the information, all the work that we did on the base certification guide. But it's also a way for us to try out a subquery. So here's the code using a subquery. Let's make a new table. I'll call it example. I'm going to create it as the following select statement. So pick everything from DMEF1.trans. Now here's the subquery, where the subquery comes in. We're going to take all records where code is in this set. Well, which set? It's a subquery. Select code from the DMEF1.1 code where code type equals A. So we're going to pick all the codes that have a code type of A. It's going to make a big list. And then we're only going to keep records up here where code is in that. Only keep records from the trans file where code is in that set. So that would be one way to accomplish this. Now, another way would be to do this with a select statement. So here is one way to do that select statement. This is the right way to do it. So let's make a new table. I'll call this example 2 as some select statements. So pick everything from the transaction file and the one code file. But we're going to do a join where the codes match up. So the code coming from the trans file must equal the code coming from the one code file, and the code type coming from one code must equal A. So that's how we could accomplish the same thing with a merge. Now I pulled what comes out in the log. Question that I always have if there's more than one way to do something in SQL is which way is better? And so one way to test that is to look at the runtime and see which one runs faster. You're going to see that the merge version takes 1 second and the CPU time's a second, whereas the subquery version takes a bit more processing time. So it appears that the merge statement runs more efficiently than the subquery version. So if you have queries that you execute very often on very large tables, you might want to do this sort of experimentation to know what works best. Okay, I have some your turn exercises for you at this point.